Have you ever caught a snowflake on your glove and just stared at it, completely mesmerized? It's like holding a tiny, perfect jewel. But have you ever wondered why they all have that incredible six-sided shape? Why not 5 or 8? Well, today, we're going to dive into the magical world of snowflakes and uncover the science behind their stunning symmetry. It all starts high up in the clouds, with a tiny speck of dust or pollen. This little particle becomes the nucleus, the very heart of our future snowflake. As water vapor in the cold air freezes onto this nucleus, a tiny ice crystal is born. Now, here's where the magic really begins. Water molecules, H2O, have a specific V. When they link together to form ice, they naturally arrange themselves into a hexagonal or six-sided lattice. Think of it like tiny magnets that can only connect at certain angles. This fundamental structure is the blueprint for every single snowflake that will ever form. So, this tiny hexagonal prism starts its journey, falling through the sky. Its final shape is a direct record of its adventure. As it tumbles through different cloud layers, it encounters varying temperatures and humidity levels. Each change leaves its mark on the crystal. When it's very cold, around minus 15 degrees Celsius, the crystal grows sharp, long needles. In slightly warmer, moister air, it develops broad, flat plates. These plates and needles are the building blocks, the arms of the snowflake. And here's the key to its symmetry. Because the snowflake is so small, all 6 of its corners experience almost identical atmospheric conditions at the same time. If one corner grows a long, feathery branch because it passed through a pocket of moist air, the other 5 corners are right there with it, experiencing the same thing and growing in the same way. It's like 6 dancers performing a perfectly choreographed routine, all responding to the same musical cues from the atmosphere. The journey from the cloud to your coat sleeve is a story written in ice. And each of the 6 arms tells the exact same story, resulting in that breathtaking symmetry. This is why we get such a dazzling variety of snowflake designs. A flake that takes a slow, meandering path will develop intricate, fern-like dendrites. One that tumbles more directly might form a simpler hexagonal plate or a solid column. The possibilities are nearly infinite. Scientists have tried to categorize them, creating systems with dozens of different types, from simple prisms and plates to capped columns and stellar dendrites with complex branches. Each one is a unique masterpiece, sculpted by its personal journey through the winter sky. But wait, if every snowflake's journey is unique, does that mean the old saying is true? Is it really impossible for 2 snowflakes to be exactly alike? Well, let's think about the sheer numbers. A single snowflake is made of about a quintillion water molecules. That's a 1 followed by 18 zeros. For 2 snowflakes to be identical, every single one of those molecules would have to be in the exact same position. The number of possible arrangements is astronomically large, far greater than the number of atoms in the entire universe. So, while it's theoretically possible, the odds are so infinitesimally small that it's safe to say you will never find 2 identical snowflakes. Let's take a closer look at some of the most common types. You have the stellar dendrites, the classic star-shaped flakes with beautiful, feathery arms. These form when there's a lot of moisture in the air. Then there are hexagonal plates, which look like tiny stop signs. They form in slightly different conditions. And sometimes you get a combination. A capped column, for example, is a hexagonal pillar of ice that has 2 plate-like flakes growing on either end. It looks like a tiny spool of thread. It's a testament to how a snowflake's shape can change dramatically as it falls through different atmospheric layers. This incredible process isn't just beautiful. It's a fundamental principle of physics and chemistry called self-assembly. It's how complex structures can emerge from simple rules, all without a master plan. The water molecules aren't trying to make a pretty shape. They are simply following the laws of physics, bonding in the most stable way possible under the given conditions. From a single water molecule's V shape to the grand 6-fold symmetry of a snowflake. It's a beautiful cascade of order emerging from chaos. So, The next time a gentle snow begins to fall, I hope you'll see it a little differently. Each of those tiny specks of white is not just frozen water. It's a tiny diary, a physical record of a journey through temperature and humidity, a testament to the elegant laws of chemistry and physics. It's a fleeting piece of natural art, perfectly symmetrical and utterly unique. It's a reminder that even in the smallest things, there's a universe of complexity and beauty waiting to be discovered. Thank you so much for joining me on this chilly adventure into the world of snowflakes. If you found this as fascinating as I do, please hit that like button and subscribe for more deep dives into the wonders of our world. Let me know in the comments what your favorite type of snowflake is. Stay curious, and I'll see you in the next video.